Hey everyone, this is Jyotika and welcome to your 14th HTML5 tutorial. In the previous tutorial, we learned about putting images on our web page, and we also saw how to make them responsive for different screen sizes using CSS. With CSS, we could expand and shrink the same image to fit our viewport size. But there's a problem. A big high-resolution image contains millions of pixels, and all these pixels can make the image file size pretty huge. And that takes a lot of time to download on a slow network connection and can use up people's data plans. It could also cost them a lot of money. We don't want to deliver unnecessary high-resolution data to small screens. Instead, maybe we should just make all of our images much smaller. Physically smaller, less colored data, fewer pixels, more compressed, which we also learnt about in my previous tutorial. But that will work well only for smaller screen. If we send that image file to everybody, people with big desktop monitors won't get to see a large and beautiful picture. They will get a low quality picture blown up really big. So what can we do? Well, in today's video, we are going to see how we can use the power of HTML to send different image files to different screens. Or in short, we are going to understand how we can make responsive images using HTML. We can make several different files and write them as a set of options in our image tag, and let the browser decide which image to download. Let's first start with the basic code for loading an image on the page. I've opened the same animals.html page that we were working on in the previous video, but I'm just going to take out the previous code to reduce the clutter on the page for today's demo. I will add it later when I send out the file to you, so you have all the images code on one page. So you can start on a brand new HTML file if you like, or continue on the same. Now, I'm adding an image element here with the source, the alt text, and the width and the height, just like we learned in the previous tutorial. And you can see here that I wrote 480 in bold on the image itself. So it's obvious which image has loaded when. Now this image is 480 pixels wide, and it will look good when it's displayed at 480 pixels or smaller on some devices. But more and more screens these days are not 1x screens. There are many advanced screens like retina screens, high density, extra high density screens, and many more amazing screens. In short, there are a whole lot of screens out there with a pixel density of 1x, 2x, 3x, 4x, where more data can be displayed on the screen. A standard resolution display has a 1:1 pixel density or 1x, where 1 pixel is equal to 1 point. High resolution displays have a higher pixel density, offering a scale factor of 2 or 3, referred to as 2x and 3x. As a result, high resolution displays demand images with more pixels. For example, suppose you have a standard resolution 1x image that's 100 pixels by 100 pixels. The 2x version of this image would be 200 pixels by 200 pixels, and the 3x version would be 300 pixels by 300 pixels. In fact, if you see this image on a laptop, which has a high resolution screen at full screen, you can see the image looks kinda blurry. You will notice it more around the edges, and also this number. It's not that clear. So, to support these different screens, we need to create multiple copies of our image in different resolutions, and then tell the browser that those copies are available. The browser can then decide what it wants to do. The browser will look at the screen density, the network connection, and decide which image to use. And that means even if someone has a high resolution screen, the browser might sometimes decide to download a lower resolution image. So I have created 4 copies of this photo at 480, 960, 1440 and 1920 pixels wide. It is possible that the pixel numbers for these images are not totally precise, but the aspect ratio is what's important here. And 480 by 320 calculates to a 3 by 2 aspect ratio. All of these photos are 3 by 2. And now, instead of displaying all 4 images at once, let me go ahead and change this code to load just one image at a time according to the screen resolution. So I will just copy and paste this code of the first image and delete the rest of the image tags. But I am going to keep this first 480 pixel image as it is for comparison purposes. Now in this image element that we copied here, we are not going to touch the source, alt, width and height attributes, as we are still going to need them to display the 480 pixel image. And since this image is our smallest image size, we are going to display it on 1x screens or lower resolution screens. Now to add our other higher pixel pictures, I am going to create a source set attribute in this image tag. The source set attribute specifies the URL of the image to use in different situations. It defines the set of images we will allow the browser to choose between and what density or width of each image is. Each set of image information is separated from the previous one by a comma. For each one we write an image file name, a space, and the image's density like 2x, 3x, or intrinsic width in pixels like 960W, 1440W. So in between the quotes, I am going to write the next image's URL, that is the 960 pixel image, followed by a space, and then the resolution of the image. So this image is 2 times the size of the original 480 pixel one. So I will just write 2x here. And then for writing the next image of a different resolution, I just have to type a comma after this 2x and then follow the same steps. The image URL, space, and now 3x. Similarly, I will also add the 4x one. You can add even more images ahead separated with a comma. As easy as that. There is no limit to the number of source files specified in the source set attribute. It's not necessary to put 1x for the smallest image. It is understood that it is 1x. Also, remember to keep the source of the image. It will act as a fallback if some browser does not support the source set attribute, although most browsers support it now. So all we are doing here is telling the browser about some images that we have available and what size they are. The browser then does all the work figuring out which one will be the best. So let us save this and have a look at our browser. And you can see the image which was 960 pixels wide is now displaying on our web page and not the 480 pixel one. This 960 pixel image was written in the source set attribute for 2x resolution screens. And therefore the browser was like, okay, since I am a 2x display on this laptop, I am going to throw out the 480 pixel image because it's too low for me and it might look bad. And I am going to use the 960 pixel image. However, the image will still display on the website at a visual size of 480 by 320 as we have restricted the size of it in the width and height attributes and added this CSS of max width equals 100%. So it will always look like it is 480 pixels wide on a full screen. But we are doubling the pixel density by using an image that's double the size at 960 pixels. Similarly, if I open this web page on say a Pixel 2 mobile phone, you can see the browser chooses to load the 1440 pixel image, as that phone probably has a 3x screen. But if I open it on an iPhone 6, 7 or 8 phone, Then it chooses the 960 pixel one, as it might have a 2x screen. I've put a link to this code in the description below, so even you can go ahead and check out this web page on your laptops and phones and see the difference. But remember, sometimes the browser might choose to load a lower resolution image on a high resolution screen. It depends on your network connection and user settings. And if you want to test out different devices right from your laptop, just like I am doing, then you have to do a couple of things for it to work. First, right click and inspect, then go here and click on this device toggle icon, which should open up a mobile device emulator. Then you can see some devices here and you can click on them and test out. But remember one more thing. Once you have loaded a higher resolution image, you might not see a lower resolution image even if that device has a lower resolution screen. Because the browser caches all your downloaded data, and if it has already downloaded a higher resolution image, then it will be like, okay, since I already have a better image, let me display that. So for testing purposes, you can go down here and click on network and then disable cache. So now whenever you choose a new device, you just have to refresh the browser to download again. So yeah, SourceSet attribute is a great solution for providing different size images to handle Retina and other high DPI screens. But it's not that great for mobile devices. We don't need such high resolution images for a small screen. A high resolution image and a low resolution image will look almost the same when viewed on a small screen of a mobile phone. And high resolution images can eat up on the bandwidth and make loading of your site really slow if you have a bad network connection. So what if you wanted different size images based on the layout, based on the width of the page, as well as the pixel density of the screen? Let's look at that next. It's very similar to the one I just showed in this example, with 4 images listed inside of a SourceSet attribute, but this time instead of saying 1x, 2x, 3x, 4x, we will tell the browser how wide each file is. 480W, 960W. That means we are telling the browser the actual sizes of the images, which are 480 pixels wide, 960 pixels wide. Note that this uses the W unit and not px as you might expect. This is the image's real size, which can be found by inspecting the image file info in your computer. Now the browser will choose which image to display based on a combination of the device's screen density and the entire viewport width. But the problem with mentioning the image widths like this is that the browser is not going to pick the right size image for the layout that you have on your page. It will choose an image based on the assumption that you need the image to be 100% of the viewport width always. But we don't need our images to be always displayed at 100% width. Even if we need them to be 100%, it is always better to display the smallest size image that will look good. So say for example, if this was a smaller viewport device like a mobile device, then the browser chooses to load this image, which is at 960 pixels. But if we want this image to be displayed at only half its current size, a lot smaller than the entire viewport width, then let's see what the browser does. So let me change the CSS to max width 50% to display our images at half their current size. And if you look here, the browser is still loading the 960 pixel image, which is not really necessary. We don't want to download such a huge amount of data for an image that is going to be displayed on a small device. So what can be done here? How do we tell the browser about the size of the image in the page so that it can download the right source from our SourceSet list? That's when the sizes attribute comes to the rescue. The sizes attribute is required anytime you use SourceSet with width descriptors like the 480W or 960W. In fact, sizes only make sense if you are using the width descriptors. If you are using display density descriptors like 1x, 2x, then you don't need the sizes attribute. The browser won't know what to do with it. With sizes attribute, you can add media conditions for various viewport or screen width breakpoints, at which you want the browser to choose another image. It gives the browser a set of hints as to what image size would be best to choose when certain media conditions are true. It is written like this, with a media condition mentioning the size of the viewport or the screen width of a device, a space, and the width of the slot the image will fill or the length of the viewport the image will occupy. So first, you write the word sizes and then equal to and quotes just like a regular attribute name, and then you have to write a media condition like this, a round bracket, then max width, colon, and then whatever viewport of any device you want to mention. In this case, I am writing 480 pixels, which also happens to be our smallest image size, but it can be anything. Just start with the smallest size here, and then a closing round bracket, then a space, and then the width or amount of space that your image will be occupying on the mentioned viewport size. Since I am displaying the images at half their size on the page, I will write 240 pixels here. That's half of 480 pixels. It represents the width of the slot the image will fill. The unit here for the slot width can be an absolute length like px like we wrote, or em, or even a length relative to the viewport like vw, but not percentages. Today we are going to see only px. So by writing this line, we are saying when the viewport width is 480 pixels or less, look at the slot size of 240 pixels mentioned in the condition and load the image referenced in the source set list that has the same size as the slot, or if there isn't one, the first image that is bigger than the chosen slot size of 240 pixels. So there is no 240 pixels image in our source set list, but the closest to it is the 480 pixels one. So if the viewport width is 480 pixels or less, then the browser will choose to load the 480 pixels image, our smallest image. Similarly, you can write more media conditions for supporting bigger viewports like this. The browser ignores everything after the first matching condition, so be careful how you order the media conditions. And in the end, I have written just 1920 pixels without any media condition. When there is no media condition listed, the length specified here is assumed to be a default value and is used when none of the other media conditions are met. In here, we have media conditions covering viewports up to 1440 pixels. That means from viewport sizes of 1441 to infinity, the image will be 1920 pixels wide. But the browser takes our media conditions only as hints. Ultimately, it will display an image taking into consideration both the width it will use on the page as well as the pixel density of the screen or the resolution of the screen. It does some math looking at our media conditions and the source set list and chooses what it feels is the best choice. The source set and sizes attributes look complicated, but they are not too hard to understand if you format them like this, with a different part of the attribute value on each line separated by commas. So let's save our code and test this out. You can see now that the second photo looks just as good as before. But do you notice that now the browser is using a smaller file for a smaller viewport? Instead of using 960 pixels, it is using the 480 pixels image. Now I'm slowly going to expand this browser. Notice the changes in the width breakpoints above. For a viewport between 480 pixels and 960 pixels, it is loading the 960 pixels image. For a viewport beyond 960 pixels, it is loading the 1920 pixels image. Somehow it skipped the 1440 pixels, but again, it's because in the sizes attribute, we aren't saying which specific images should be used. We are just telling the browser what size the image should be on the page. If you want, you can even see the changes by selecting different devices from here. But remember to keep refreshing after each selection. For this Surface Duo device, it is showing the 1440 pixel image. So yeah, the browser is definitely using smaller files than before, and it's using the files that are the right size and most optimal for the layout that we have specified. The 1920 pixel picture is 261 KB on disk, whereas the 480 pixel version is only 23 KB, a saving of 238 KB. Now imagine if this was a page that had many pictures on it. Using these attributes could save mobile users a lot of bandwidth. So it's definitely worth to take that extra effort and provide source set and sizes in the image element for improved web performance. I had to do a fair bit of research for understanding source set and sizes and making this video. I refer to a lot of material. So if you want to read more about this, then I've put some informative links in the description below. So don't forget to check them out. Now let's quickly review. Using responsive images means providing the browser with multiple image sources depending on the display density, size of the image element in the page, or any number of other factors. When we want to display identical image content, just larger or smaller depending on the device, we can use the source set and sizes attributes. They provide several additional source images to help the browser pick the right one. Source set defines the set of images we will allow the browser to choose between and what size each image is. The size of the image in source set can be written as image density descriptors, the 2x or 3x, or as image width descriptors, the 960W or 1440W. Sizes defines a set of media conditions or screen widths and indicates what image size would be best to choose when certain media conditions are true. These are the hints that we talked about earlier. Using source set and sizes together could save mobile users a lot of bandwidth and can also improve the performance of your website. And that's it for today. But there is more to responsive images. And in the next tutorial, we are going to learn more. So stay tuned. And don't forget to check the links in the description below. Also, let me know in the comments if you have any questions. This is Jyotika signing off. Until next time, keep learning and keep coding.